Hello students, today we are going to start the chapter set theory. This is the new discipline of mathematics. This is first chapter of class 11th in NCERT. In this chapter, we have to understand the terminology of set theory and how to apply this set theory. So what is this set theory? Actually, when we have to understand the language, let's say English, we have to understand the alphabet and we have to learn the alphabet. In the same manner, when we have to understand the language of mathematics, like real analysis, calculus, and other things, then we have to understand the terminology that's known as set theory. Set theory was first given by Cartan. But after that, lot many mathematicians involved in this to develop the set theory. John Venn was there. He has given the graphical method to solve set theory. Euler also given a very good formula. De Morgan formula is one of the best formula we have to learn in this set theory. De Morgan formula we will use in probability, permutation combination, and other mathematical problems, right? So in this whole, right, in this lecture, we are going to study terminology of set theory, right? So let's start and enjoy this topic.
In this topic, we are going to start with the terminology and the basics of set theory. So first we are starting with what is this set theory? What is the meaning of this? This is the first time we are studying about these type of language. So first we have to understand what is this language. This is the language of mathematics. We have to understand how to define this. So what is set? The collection of well-defined, first is well-defined, distinct objects. Well-defined and distinct. What is the meaning of well-defined? Well-defined means when we are very specific about the set or specific about and we know the property of certain thing, like if I'm saying states in India, all the rivers in India, right, all the districts of Maharashtra, right, we are very particular about this thing. So this is known as well defined. If in a class we are defining the name of the students, right. Second thing is distinct. Distinct means different, right? So these two are the necessary thing for any set, right? As well defined refer to the specific property which makes it easy to identify whether the given object belongs to the set or not. And as I said, distinct means the object of a set must be different. So it must be different as well as well defined. So the set is well defined group of objects. Like first we can take example of people in a class: Ram, Syam, Hemal, Heman. The name, the particular names are there, right? Like class offered by a department, whether it's physics, chemistry, mathematics, bio, or anything would be there, right? Colors of a rainbow, that's very fixed. We know that red, orange, yellow, green, blue, and so on, right? The state of matters, states in India, right? But it may be possible you are getting a set not relating thing, but we can define this as how we have to define this is required for the set. Mostly we have to use this thing with the number set. Number sets, we know that as we are defining as all positive numbers less than or equal to 5, right? So all positive numbers less than and equal to 5 and integers are there, right? So this is well defined. We are saying all positive integers less than or equal to 5. So you are getting 1, 2, 3, 4, and 5. Right? This is well defined as well as distinct 1, 2, 3, 4, 5. Right? No repetition is there. Maybe I'm saying few of the real numbers are there. 2.1 is a rational number. Pi is an irrational number. 0 rational number. Minus 1.123 rational number. E irrational number. So we can define accordingly, right? The requirement is there as well as we can define the distinct means, right? Distinct means we are saying do not have to duplicate elements. Do not have to duplicate element. What is the meaning of this duplicate elements? Like if I'm writing the vowels, right? A, right? E, right? These O are repeating there, right? So this is called the duplicity or the duplicate. So in set theory, we have to write down A, E, I, O, U as single one, not repeating the numbers. You have not to repeat this, right? So this that I was saying, this is the language. In this language, we have to define certain thing in this way only, right? Now, why this is so? Let's take an example. If I'm saying he considered the list of a student in the class, right? Now, if I'm writing the name of the student and I'm writing the name of the student, one student again and again, right? Again and again, I'm listing down the same student. It's very difficult to define exactly what I mean to say, what are the numbers there, how many number of students are there. So for the particularity, we have to be distinct and well defined. The origin, right? Cantor was the person who have invented this theory, this fundamental of set theory. But many more mathematicians were there, like Venn was given the tool to understand this set theory. Graphically, how to understand this, right? Euler was the one of the like renowned mathematician whose contribution in set theory is like lot many things he has given in set theory. Pascal has given lot many things in the set theory. So this set theory in a whole we have to understand, but this is a new language, so we have to understand exactly what is the meaning of this and what are the terminology we are going to use in the set theory. So one by one we are coming for that, right? But first we have to understand how to write, how to define this set theory, right? First thing, in any set, in any set, order does not matters. Order does not matters if you are writing 1, 2, 3, 4, and 5, and that is equivalent to the same number in any other orders, right? When you have to write down the sets, define the sets, it must be in curly bracket. Curly bracket define the discrete things. This is the curly bracket. You have to write down the number or the specific thing in between, right? Some thumb rules are there, like representation of a set. Thumb rule we are taking as the alphabets, capital letters A, X, S, or any other letter you are taking. This is for sets. If you have to represent sets, you have to represent with the capital letters, right? Elements are usually represented by italic lowercase letter A, B, C, D, small a, B, C, D. These are the elements inside the sets, right? So easiest way to list the element, this is one of the easiest way. A is equals to, right? A is equals to, set A is equals to curly bracket. Inside the curly bracket, you are taking the numbers 1, 2, 3, 4, and 5. This is very good method for finite number of elements. But when we have to go for infinite, right? Like real number, natural numbers, all the numbers you are going to infinite up to infinity. So we have to write down all the numbers. That's not possible. So we have to represent the sets in different forms. So representation of sets. First method. First method is known as roster notation. Roster notation is the method where we have to describe the set by listing down each and every elements. Like I'm representing any set B as 0, 1, 2, 3, 4, 5, 6, and so on. If only 4 5 numbers are given, then it's okay. But this is little bit confusing. The confusion is like, if I'm giving you an example, like there is a set C, and C I'm writing 3, 5, 7. And now if I'm asking, careful students, now if I'm asking what is the next number? So maybe few of you will say, sir, 9, because this is odd number greater than 1. So this coming as 3, 5, 7, 9, 11, and so on. But maybe few other students are there, they can say, sir, maybe this is represented as all the prime numbers greater than 2 or odd prime numbers. Then it will be 3, 5, 7, 9 is not a prime number, so it will go to 11 and 13 and 17 and so on. So there is some confusion in this. That's the reason it's difficult to write down every time in this way, the roster notation way. So we need something more to represent these type of numbers when this is going to infinity, and the order we know, and we have to specify that what is the order. This is known as, the second method is known as set builder notation. Set builder notation is nothing but we have to convert our mathematical form in English language. How we are doing this? Right? Like I'm defining set D. X, this is read as X. X is such that X is a prime and greater than X greater than 2. Or E defining X is such that X is odd and X greater than 2. Right? This vertical line, right? This vertical line you have to read such that, right? So how we will read the complete thing? All elements X such that X is prime and X greater than 2, right? Now, so in set theory, some special sets, special numbers are there, right? And obviously we know these type of numbers. Like first we are representing n as natural numbers. Natural numbers, we believe that the numbers are in the nature was 1, 2, 3, 4, and so on. These numbers are in nature, so these are known as natural numbers. But these numbers are not completed without zero. The wholeness or completion of number possible with zero only. So this including zero, this set is known as whole numbers, right? Now again we are going ahead with this. If we are adding, or we are putting all the negative of the natural numbers also in this, so this is known as integers. Usually this is denoted by Z. Somewhere you'll find this is I also, right? Q is the rational numbers. Rational numbers means it defined is a form of P by Q, where P and Q both are integers, but understand Q is not equals to 0. When Q is equal to 0, like if I'm writing 5 upon 0, then this will be not defined. Number is not defined, right? So this is represented as Q is a rational number. Q dash is irrational number. If we are not able to define the number in the form of P by Q, then this is known as irrational number. R is called the real number, the complete set. If you'll include all these things in one go, then these all are coming into R. That's called the real number. And C is overall called the complex number. This is the new thing we have to study. Now, the terminology we have to see. Belongs to or not belongs to. What is the meaning of this? Belongs to or not belongs to. A set is said to contain the various members or elements that makes up the set. Like if an element A, right, is a member of or an element of set S, we use this notation as belongs to A belongs to S. Means A is the element that is in the set S, right? Like if I'm writing 1, 2, 3, 4 and there is a number 4. So 4 belongings to this set 1, 2, 3, 4. And what if does not belongs to? Then again you have to write down first belongs to, then cross it. Then this will be the sign of does not belongs to. How question will get, right? 7 does not belongs to 1, 2, 3, 4. Right? Obvious सी बात है. Right? Non-related thing may be there, like India does not belongs to some number 1, 2, 3, 4. Obviously, it must not be belonging there. Right? Next terminology, universal set. Usually, universal set is denoted by this U, right? Italic U, that is called universal set. But one more U will come for union, that in set theory only we have to study, right? This is called the universal set. Now, the universal set is the completely, something is completely containing each and every elements. Like natural number was there, right? So natural number will be contained by whole numbers, right? Now this is whole number and this is contained by integers, right? Then integers are contained by rational numbers, P by Q, right? Q, right? Q dash was different from this, right? But whole this thing was contained by real number and so on, right? And then the complex number and on, right? So this R is for this purpose we can say ki R, the real number, is containing each and every natural, whole numbers, rational, irrational, everything, right? This contain each and everything there, and right? Like in the set -2.42, right? This U would be real number. In the real number, each and every number -2.42, everything is coming. But if I'm saying 0, 1, 2, 0, 1, 2 may be contained in whole numbers, right? Maybe it's going for integers, maybe it's going for rational number, maybe for real number, maybe for complex number. So it can contain each and everything in the right number. So universal set we have to define, right? That must contain each and every elements, right? For a set of a student in this class, right? In any class, set of the students are there, right? Maybe if I'm taking a school in Delhi, right? So the students belongs to Delhi, students belongs to India, the students belongs to Asia. So universal may be Delhi also, India also, Asia also, universe also. So it depends on ki how much big we can take as a universe and what is our requirement as a question. Like vowels of an alphabet, right? So universal set will be the letter of the alphabets. So everything will be there, right? As I said, U and U both are different things, right? This U is for union, that we'll study in this chapter only. Now we are starting this class with Venn diagram. Venn diagram is given by John Venn in 1880. This is one of the very good fundamental. We have to understand mathematics with the help of graph or with the help of the pictures, right? So, representation of this graphically. The set theory we have to represent as graphically. This first, this square you can see or the rectangle, this is known as universal set. Usually we represent this as universal set U, and the circle is called the set. The circle is known as the set given by X. So U is the universal set and X is in between. There is a set that's given by X. Now let's suppose I'm saying that this X is all the vowels. Vowels means we have to fill X as A, E, I, O, U. And let the universal set in this is all the alphabets. So each and every alphabets are coming, but the vowels are coming into X. But in the universal set, you can see all the other alphabets are there, not inside X. So this is one of the best way to represent set theory graphically or by the diagram, right? So individual elements we can write inside X or U that will represent our set theory, right? Now, if we are writing a set S. So this S can be, earlier we have seen that this S is in the curly bracket. We have to always start the numbers we are writing 1, 2, 3, 4 and so on. But inside this S we can also write down the sets. And maybe these sets will be like 1, 2, 3. Maybe these three are there. Only three elements are there, right? 1, 2 and 3. Right? 2, 3 curly brackets are there. Again, set X, we can see one element is this one, second is this one, and third element is this one. So three elements are there, and this is represented as more likely as like we can write sets inside the sets. So this is also the notation, but you have to understand these notations are different. This is different element, this is different element. Maybe in one set only you can write 1 and with the curly bracket 1. Both the elements are different, right? Both the elements are different. So next is empty set. By the name only we know that empty means nothingness. Nothing is there. So set theory, if no element is there, this is known as empty set or null set, right? Usually denoted by, this is known as phi. This is phi, right? But you have to understand this phi also you can write with curly bracket and not writing anything in between two curly brackets. If you are not writing anything between two curly brackets, means this is known as phi null set. We are not taking any number of elements, right? So this and this both are same, right? No difference in these two. Maybe somewhere we can find this phi, or maybe somewhere you can find this curly bracket, nothing is there, right? But this is also a set and phi is there, that's given in the sets only, right? So this phi is a element in this case, right? But you have to understand this phi means null set, but this represent a set that contain phi as an element, this having one element, right? Right? But this having no element, empty set. Both are not same. First having zero element, but second having one element in this, right? Now you can understand like this key, if phi and null set both are same, the null set is represented like this. So obviously this represent as an element, so we can't write two sets as empty set inside any set, right? So both are not equal. Now, set equality. Two sets are equal if they have the same elements. Already we have studied like 1, 2, 3, 4, 5 is given and 5, 4, 3, 2, 1 are given. In set we know that order not mattered. So order of the numbers 1, 2, 3, 4, 5 and there 5, 4, 3, 2, 1 both are different but the elements are same. So these two will be same. Order does not matter in this. And also the repetition. If repetitions are there, two ones are given, two twos are given, two threes are given, ultimately you are getting this number as 1, 2, 3, 4 only, right? So two sets are not equal if don't have the same elements. If you don't have same elements, like 5 is not there, right? So these two elements are not same.